Today is the last day of this chapter 7 notes here. There is a 28 desk, isn't there? No 16 now. Okay. All right. Here we go. So today we're talking about law of cosines. Law of cosines looks really long. It looks really weird. But it's really just a pattern. And if you can get used to the pattern, then it's actually pretty easy. So, just like law of sines, law of cosines can be used to find the side lengths and angle measures for any triangle. It doesn't just have to be a right triangle. So right triangles, we can simplify things really just with sine, cosine, or tangent. But if it's a non-right triangle, we can use law of sines or law of cosines. To become a math teacher, we have to take a math exam, meaning it's all math from, like, for 6 to 12, it's all math from, like, middle school math all the way through probability and statistics at the college level. So it includes calculus and all kinds of stuff. Well, we get like a formula sheet, and law of sines and law of cosines was on there, and for the life of me, I was like, I have never seen this before, which was really kind of interesting. I did pass. Yes, I did. All right. Good morning. Here we go. So this is for triangle ABC. So again, I just want to reiterate, when we have a capital letter, the side opposite is the lowercase letter. All right? And again, to reiterate, if you have a triangle JKL, what side is opposite angle J? Little j, all right? And what side is opposite angle K? Little k. And what side is opposite capital L? Lowercase l, which I write as script letters just to avoid confusion. But it is important that you understand how to set up these triangles, and they're going to use different letters, okay? So it's not always A, B, and C. So here is what we've got. First of all, I like to highlight the angle and its opposite side. So once again, we need to have that angle and opposite side connection. And so here is, I'm just going to give you one formula. She has it written 3 times, but it's the same thing. So if I have an angle and an opposite side highlighted, I'm going to start with the length of the side squared. So little a squared, watch your capitals here, is equal to, so the side squared is equal to, we have 2 other sides here on either side of our connection. Do you see that? Okay. A squared is equal to B squared plus C squared. So those are the squares of the 2 sides, the 2 other sides, minus twice the product of those sides. What does twice the product mean? 2 times, and what does product mean? Multiplication, multiplying together. So the product of those 2 sides, so B times C, twice the product, times the cosine of, I'm going to actually write that in pink, the cosine of the included angle. So it's the cosine of angle A. So you can see that it starts with your side squared, and it ends with the cosine of that angle that is opposite. All right? And it's just a pattern. So do you recognize sort of like what does a squared equals b squared plus c squared? What does that kind of remind you of? Pythagorean theorem, absolutely. Okay. And in fact, once I did this, I was like, oh, I should have used c. But whatever. Okay. So all it is a pattern. So our opposite side squared equals the square, the sum of the squares of the two other sides minus twice the product of those two sides times the cosine of the included angle. All right, the cosine of the angle in between. All right, and that's it. It's a big long thing, but once you write it down, it's just calculator work. Okay, so we're going to use law of cosines here on number 1, and you'll catch on really fast. I need you to follow along with the calculator because this is the big part here. Do we have an angle and an opposite side info? Yes, we have an angle and opposite side right there, what we're looking for. All right, I want you to circle those and connect them, please. All right, we start with the side squared is equal to the sum of the squares of the other two sides. So what are the squares of the other two sides? 7 squared and 12 squared, absolutely. 7 squared plus 12 squared. All right, minus twice the product. What should I write? Twice the product of the sides. Twice is 2. 7 times 12, twice the product of the sides, twice the product of 7 times 12, times the cosine of the included angle. What's our included angle? 65 degrees. All you have to do is write that down. Okay? Now let's plug it in. This entire right-hand side right now is all numbers. So that entire right-hand side can go in your calculator. What mode should you be in? Degree mode. All right? So we're going to put this entire right-hand side in. 7 squared plus 12 squared minus twice 17. I'm sorry, 7, not 17. 7 times 12 times the cosine of our 65-degree angle. Get that whole thing typed in, and we get side squared equals 122.00013, blah, blah, blah. Did you get 122.000 blah, blah, blah? Okay, good. How do you get x by itself? Square root. Square root both sides. So please, ladies and gentlemen, we're going to do the square root, and I'm just going to do of the answer. Have you used the answer button before? It's in blue right down here. It pulls in the previous answer, so you can do second answer, and it should look like that. It's going to pull in that previous answer. It turns out to be a little faster than if you actually arrow up and grab, highlight, and copy. Anyway, it's a little faster. So we get x is approximately 11.05, I'm going to say, if we were to round to the hundredths place. All right, let's try another. Number 2. I have an angle. Really important. We have to have the cosine of an angle. And then I have an opposite side that I'm trying to figure out. So again, circle those two things because we need that connection. It sort of highlights the beginning and the end of our sort of big, long formula, okay? So this opposite side squared. So we have x squared equals each side squared. So what should I write? 25 squared plus 20 squared. And then it's minus twice the product of those sides. What should I write for that? Minus 2 times 25 times 20, twice the product of those two sides, times cosine of 108, cosine of your included angle. So you can see how we begin and end with those two things we circled, and everything else is the other sides in between, all right? We're going to put that entire right-hand side in our calculator. 25 squared plus 20 squared minus 2 times 25 times 20 times the cosine of our 108 degrees. I get x squared equals 1334.0169. And then what do we need to do? Bless you. What should we do? Square root. Square root both sides. So again, do a square root of the answer. It's really important that you pull in that whole answer. Do not round it off. You will get it wrong every time in Delta Math. So 36.52 approximately. Why don't you guys try number 3 on your own? Try number 3. You can do it. One line, and then the rest is calculator work. All right. What did you get for x? Rounded to the nearest hundredth. 9.57 approximately. You would have gotten x squared is equal to 91.56539. And then the square root of that would be 9.57-ish. All right, I saw lots of good first liners there, so good job. I think that was really good. Okay, questions on that? It's not that hard, right? Just a long formula, but it's not hard. Okay. So that was to find the length of a side. So then, of course, we can also use it to find angle measures as well. Again, the setup is the same. The solving is different. So now I have an angle I'm trying to figure out. And I still have my opposite side connection, so that's good. So once again, I'm starting with the same stuff. So our formula was my opposite side squared is equal to the sum of the squares of the other two sides. What should I write? 12 squared plus 11 squared minus twice the product of those sides. So minus 2 times 11 times 12 times the cosine of our included angle, which would be, in this case, the cosine of x. So now our job is to isolate this cosine of x term, which means we have to move a lot of stuff. So we're going to do some math to get there. It's going to take a little bit of work this time. Let's go ahead and just sort of clean this up a little bit. 7 squared is 49. 12 squared, I can put this in my calculator. So go ahead and underline those two things. Let's add those up. 12 squared plus 11 squared. Those are just numbers, so that gives me 265. And then I have a subtraction sign. I can also multiply 2 times 11 times 12 together. So I'm going to do a little bit of math work here. I'm going to multiply 2 times 11 times 12. That gives me 264 times the cosine of x. Do not do 265 minus 264. That is not a thing, okay? This has a cosine x fanciness on it, all right? These are not like terms. This is a regular number. This is totally messed up. It's got a cosine x on it. It's not the same. Do not combine. Instead, I'm going to subtract this 265 because I need to move it away. Our job is to isolate cosine of x, so all this stuff needs to be pushed to the other side. So I'm going to subtract 265. Write down these steps, ladies and gentlemen. Write down these intermediate steps so you know what we're doing. So 49 minus 265 is negative 216 equals negative 264 times the cosine of x. All right, this is negative 264 times the cosine of x. How do I get rid of this negative 264? Divide it, absolutely. So we're going to divide both sides by negative 264. Get rid of that number. Again, our job is to isolate this cosine of x. So I have negative 216. I'm going to divide it by negative 264. And I get this crazy decimal point, 81818 equals cosine of x. Now, right now the x is trapped inside a cosine function. How do we get rid of the cosine? Invert cosine. Yeah, cosine inverse. We're going to take cosine inverse of both sides. So again, smush it in. It is 100% mathematically correct, and you'll be able to know what you did the last time. So cosine inverse and cosine cancel each other out, all right? Leaving a nice free x, and then all I have to do is cosine inverse of my answer. So I'm going to do second cosine inverse, second answer, so that I'm taking my cosine inverse of my previous answer right there. And I get 35. What does that round to? We round to the hundredths. 0.1, yes, degrees. I guess I'll give that a little approximation there. All right. So this finding the angle does require a lot more work. Again, once you learn the pattern, it's actually not going to be that hard. Most of it you can do on your calculator. But that first line is clutch. So let's look at one more here. Number 6. We have an angle and its opposite side. Two important parts of law of cosines. Oh, no, fine. So we're going to start with the opposite side squared. So that would be 35 squared is equal to what plus what? 16 squared plus 24 squared minus what?
2 times 16.
Good. 2 times 16 times 24 times the cosine of x. So that is the first line. And then we need to do a little bit of cleanup. So now with our cleanup, we can do a lot of math on paper here. 35 squared is 1225. I can do my sum of squares, 16 squared plus 24 squared gives me 832. And I have my subtraction sign. I can multiply the 2 times 16 times 24 as well. So clean up your numbers. We get 768 times the cosine of x. So number cleanup, then what should we do? Minus 832, very good. From both sides, so 1225 minus 832 is 393 equals negative 768 cosine of x. Then what? Negative 768. Divide by negative 768. We want those whole numbers to disappear. So I'm just going to take my answer, divide by 768. And keep that running answer in there. It makes the math real quick. Minus 0.5117 equals the cosine of our angle. How do we free our angle? Cosine inverse of both sides. Cosine inverse of both sides. Again, just smush it in, ladies and gentlemen. That's so important. We math teachers love to see you're understanding your inverse operations. All right, so I'm going to do second cosine inverse of my answer. And I get about 120 point, to the hundreds would be 78 degrees. But again, Delta Math is going to change what to round to every time, so read carefully. Do you have questions for me? Do we need to do another? No. They are super formulaic, so I think you'll probably be fine if you copy down the notes. Good.